Okay, everyone. Hello, hi everyone who are here and who are online. Welcome again to the second part of Phonology, Brain and Society, hosted by ELL and also by the Phonetics and Pronunciation Special Interest Group, which is relatively new. Before we start, we would like to again acknowledge that all this would not be possible without the support of the International Research Collaboration Fund. And we also want to thank ACIS, and also especially Lynette, who's there, for helping us so much with this. If you have questions about the talk, please ask at the end. You can put it in the chat if you're online, or if you're in person, we can ask at the end. So I'm very excited today to introduce our first speaker. So that's Katrina Lee. She's a final year PhD student with the Department of Theoretical and Applied Linguistics at the University of Cambridge, UK. She currently works on prosodic focus in Chinese languages, and in simpler terms, how certain parts of an utterance of a speaker are made prominent. Yeah. And she has already published in a few papers in top journals in the field that looked at her area of research, and also on L2 learning of tones, right? And today, Katrina will be talking about one of her studies on lexical tonal effects in code switching. So can we maybe welcome her?
A few colleagues from Cambridge. It's about tonal aspects of code switching.
Is it not working?
It's good.
Okay, let's try again.
Or I can. It's the one this one.
Does it work? Oh, okay.
No. Sorry,
Let's reset it.
It can for it.
Oh.
That's right.
Yeah, it should work, yeah.
Sorry, guys. It was working just a moment ago. So let's continue. Code switching refers to the phenomenon whereby language users use two or more languages in one utterance or discourse. So here I'm showing an example from the SEAME corpus, which shows the Mandarin-English code switching. 然后我等 taxi all the way until 11 o'clock. I hope you find the example familiar to you because the corpus is about Southeast Asian Mandarin-English code switching. It's actually developed here at NTU. So I'm very happy to present some findings based on this corpus data. So most studies to date have focused on the social variables or grammatical factors conditioning code switching, and we know relatively little about the phonological variables. So why would you think the tonal effects might be there in the code switching? So this line of thinking is based on Clyne's series of work, especially his triggering hypothesis, and later on developed as a facilitation principle. So the idea is that certain lexical items that bear similarities between the two languages might facilitate the code switch from one language to the other. So it's like they create an intermediate zone so that it's easier for people to code switch. And in the prosodic domain, Clyne makes specific hypotheses about the effect of lexical tones. That lexical items in the tone language whose tone is identified with the pitch and stress of the non-tonal language in contact are liable to facilitate code switch. And this hypothesis has found to some extent, some empirical support. For example, in Vietnamese to English code switching, 80% of the switches occurred after Vietnamese mid to high level tones. And this is based on Vietnamese speakers. And then June 1997 found in bilingual children in Australia that they code switch from Mandarin to English following the falling and neutral tones. But these studies, in a way, they're small in scale and did not consider other factors such as grammatical categories or their frequencies. So we want to extend this line of research by looking at the relationship between lexical tones and code switching in the context of 3 tone languages, which are Mandarin, Cantonese, and Vietnamese. And we asked 2 questions. Firstly, does lexical tone affect code switching between a tonal language and a non-tonal language? And secondly, is this effect or lack thereof universal or language specific? So here are the 3 corpora we used. For Cantonese-English code switching, we rely on the HLVC corpus, which includes speakers from both Hong Kong as well as the heritage speaker community in Canada. And for the Mandarin-English code switching, we rely on the SEAME corpus developed here at NTU. We rely on the public available dataset online. And then for Vietnamese English code switching, we use the CanVEC corpus, which is developed by the second and third author of this paper. So these 3 corpora, they are compatible in their format, in their type of speech, and also in their scale, to provide us with a basis for comparison. We mostly rely on the transcribed natural speech, so we're not analyzing the actual audio recordings, but mostly the text transcriptions. So since we are focusing on the lexical tones, briefly introduce the tonal system in the 3 languages. Cantonese, Mandarin, and Vietnamese, they all have a very different tonal system. Here's a schematic representation of their pitch contour of their tones. So Cantonese it has 6 tones. Additionally, there are 3 check tones. The check tones are syllables which end in unreleased stop coda. Because their pitch level matches certain unchecked tones, so we group them. We group the check with the corresponding unchecked tones. And it's the same for Vietnamese. There are 2 check tones in the language, and they're grouped with the non-check tones. And in Mandarin, in addition to the 4 widely known tonal contours, we also include another category, which is the neutral tone categories. Let's be aware that although we use a label for all these languages, but they actually mean quite different things. So tone 1 in Cantonese is different from Mandarin tone 1, it's different from Vietnamese tone 1. They are not any relationship with these languages. And for our processing procedure, how we process the corpora, we mostly base on the method by Clyne and Clyne, the second and third author, developed for the CanVEC method. And here I'm presenting how this method is extended to the Chinese languages. So first, based on the character encoding, whether it is encoded using Chinese characters or English letters, we divide each sentence into chunks, the Chinese chunk and the English chunk. And then each sequence was processed by the relevant word tokenizer and part of speech tagging toolkit. So for Cantonese, it is Pi Cantonese. For Mandarin, it's Jieban and Spacey. And for English chunk, it is processed by the Spacey model as well. So those toolkits do 3 things. Firstly, they tokenize the string. For example, here there's a phrase, in Cantonese, and then the toolkit will divide the phrase into words, divide into mo and hoiti. And secondly, the toolkit also assign a part of speech tag. So whether it's pronoun, noun, particle, or verb. And additionally, this toolkit can also convert the Chinese characters into their romanization system. So for Cantonese, it is Yupin, and for Mandarin, it is Hanyu Pinyin. So based on the romanization, we are able to have the tone information to extract from the corpus. And then we assign language label again to the sequence, so based on the tokenized data. In addition to English or the corresponding tone languages, we also include a 3rd category, which is the language neutral labels. So language neutral are the units which are not exclusive to any languages. So those are like proper nouns or interjections and fillers. For example, in Singaporean English, we have a very prominent to-the-final particle la or lay. It's very difficult to say, although these particles might have an origin in Chinese languages, nowadays it's very difficult to say which language this particle belongs to. So if you use this sentence, if you use this particle in an English sentence, are you doing code switching? This is a very difficult question to answer. So we characterize them as the language neutral labels so that the actual code switching cases will exclude those tokens. So those language neutral words are selected based on using 2 methods. So if they have a part of speech tagging with interjection or proper noun, they are considered language neutral. Or secondly, I also manually compiled a list of words mostly on the words such as sentence final particles, to make sure for all the words occurring at switch points, in the most frequent occurring words at switch points, they will not include such sentence final particles. And then finally, after this processing, we could identify the code switching point. So there will be both directions, from Chinese to English or English to Chinese. And also there's another category, which is code switching through the neutral items. But in the end, this category is very small in numbers. We exclude analysis of these categories, mostly focus on Chinese to English or English to Chinese. And finally, we will extract the tonal categories at a switch point so that we could calculate the distribution of the tones at switch points, and also extract all the information of each token so that we could later on run regression models on this data. And here I'm firstly going to show some descriptive statistics to help you have a sense of how the data is distributed. So here, firstly, we are looking at the distribution, which means we look at the code switching points and calculate, so at the switch points, the distribution of each tone. So on the left side, it shows the tone language to English switches, and on the right side, it shows the English to tone language switches. And on the left, we can look at the left side first. For Cantonese, I'm highlighting the T3, which has the highest distribution, which means at the code switching points, it is tone 3 that occurs most frequently. And similarly for Cantonese, at the other code switching direction, it is also the tone 3 that occurs most frequently. By the way, tone 3 is the mid-level tone in Cantonese. And then for Mandarin, it is tone 4, the falling tone, that occurs most often at the Mandarin to English code switching point, and it's tone 3 for the other direction. For Vietnamese, it is tone 1, the rising tone in the high register, that occurs most frequent in both directions. So there are some limits. Well, in a way, our findings is similar to previous reports on Mandarin and Vietnamese. We got very similar distribution in their studies. So this is a confirmation for us that we use compatible data set. But in a way, the distribution measure has its limitations, because, for example, if we observe tone 3 that occurs most often at the code switching point, it might be due to the fact that tone 3 occurs most often throughout the corpus, and then we have a higher occurrence of tone 3 at code switching point. So to exclude this possibility, we can also look at proportion, which means we look at the overall occurrence of each tone in the corpus and calculate the proportion, like how many of this tone occurs at the switch point. So it's a different way of looking at the data. And for Cantonese, again, we found it is a tone 3 that has the largest proportion to occur at the code switching point. And for Mandarin, now it's neither tone 3 or tone 4, it is tone 5, the neutral tone, that has the largest proportion at the code switching point. And for Vietnamese, it is tone 1 in the direction from Vietnamese switch to English, and it's tone 5 in the other direction. So there's slight deviation from the distribution data. So both of these measures, they kind of give us a first impression of how the tones appear at the code switching point. But as we said before, we cannot exclude the influence of lexical frequency or grammatical categories. So to account for these factors, we need to run a proper regression model. So we use logistic mixed effect modeling. The dependent variable is for each token, whether it is a switch point or not. So the models is run separately for the to the tone language to switch to English and switch from English. And the fixed effect variables include tonal categories, the frequency, which is continuous variable converted to zip scale, and part of speech category, and gender, generation, and language dominance of the speakers. And for random effect, we include a random intercept for speaker and token. So for the token effect, it is calculated in a way that the tokens with frequency larger than 4, they are considered as a category on their own, whereas tokens with less frequent tokens, they are grouped into the category other, so that we can enable us to include the random intercept for the token effect. So I'm not really presenting the role of the logistic regression, because our interpretation is mostly based on the post hoc comparisons of the tonal pairs. So here I'm showing the results for Cantonese switch to English as well as English switch to Cantonese. And our interpretation is mainly based on the odds ratio, the OR ratio, the OR. If an OR larger than 1 indicates a higher probability of the first tone of the pair occurring at switch points relative to the second. So for example, for the third line, tone 4, compare tone 4 and tone 3, the OR ratio is smaller than 1, which means tone 4 has a smaller probability to occur compared to tone 3 at a switch point. So I'm highlighting the significant pairs in this table. And in a way, like we do these steps for all 3 languages and eventually reach at our, I will show you a summary table soon. In the full model, the frequency and the post-text and the speaker generation, they all have a significant effect, but this is not the main question of the study, so I won't introduce the result on those. So based on this pairwise comparisons, we reach on this summary table, summarizing the facilitating tones and the limiting tones. So basically, the facilitating tones are the tones that has the highest probability to occur, the tendency to occur at switch points, whereas the limiting tones are the tones that has least probability to occur at switch points. So I will focus on the facilitating tones. And the most robust result that is on the tone 3 of Cantonese to English code switching that seems to have a facilitating role, and as well as the tone 5, which is a neutral tone in English to Mandarin code switching result. And the other tones in parentheses indicate that it's kind of show a tendency, but it does not hold a significant result for all the pairwise comparison. So basically, the most strong effect we observe is from just tone 3 in Cantonese and tone 5 in Mandarin. And then we want to evaluate like what drives this effect, what is the reason behind why we see this tone 3 effect. It is reasonable to suspect that it is not a tone effect. It is due to certain lexical item that happens very often at the code switching point, which happen to bear the tone 3 that leads us to observe this tone 3 occurs most often at code switching point. So I'm here using this figure to demonstrate that because the ge is a particle, it's a possessive marker in Cantonese that occurs very often at code switching point. So there's a possibility that it is because this one single lexical atom occurs so often as code switching point that leads us to find out the tone 3 has a higher frequency. So is this the case in our Cantonese-English code switching results? In a way, in our regression model, we have already controlled these factors, but to make sure we can show some statistics on this as well. So here there's a joint frequency showing all the frequency information of the tokens at switch points according to their part of speech and their tone information. So we can see at the switch point, the tone 3 actually is well spread across a range of different part of speech categories, and they actually covers 71 unique lexical items that bear tone 3 at switch point, which means it's not a few lexical items that bears tone 3 to occur at switch points. Although we did see that, for example, there are three particles in Cantonese bear tone 3 that has a relatively high frequency, which 88 occurrences, but still overall it is a quite average distribution. And we can compare the result for the facilitating effect we found for Mandarin tone 5. Although from the regression model, it suggests that the neutral tone in Mandarin seems to facilitate a code switching, but actually it's the particle de and le takes up 94% of the occurrences of tone 5. So compared to Mandarin, the Cantonese tonal effect seems quite robust. And so if we say it is not driven by certain lexical items, then we think this must be due to some prosodic effects, some prosodic characteristics of the tone 3 itself. So what is special about the mid-level tone in Cantonese? We briefly look into the actual sound recordings to see the pitch contour, what the tone 3 is like at the code switching point. So here I'm showing 2 examples with the code switching at the Cantonese tone 3. Let me take it down here. The first one.
Here, break a rule.
you会 break rule, which means I'm going to break a rule. So at the switch point, we see from the Cantonese tone 3 to English, we call this, there's a slight step up pattern. So the pitch is raised a bit come at the switch point. And similarly for the second example.
低嘅 self-esteem 啦，低嘅 self-esteem 啦，
低嘅 self-esteem 啦, so which means a large self-esteem. Also, we observed this slight step up pattern. So we found this step up pattern is actually quite robust across different occurrences. So it's very often in the corpus that at the switch point, they seem to raise the pitch a bit. This is the phonetic effect we observe. And then
you break a rule. 低嘅 self-esteem 啦。
And then we try to give a preliminary phonological explanation to this pattern, why tone 3 will facilitate code switching. So this is based on a few facts about the special prosodic effects of the Hong Kong English. So Hong Kong English is claimed to be a tonal variety. So we can assign high, mid, and low level tones to Hong Kong English words. Actually, same analysis has been applied in Singaporean English, but they are very different English varieties, so the rules are different. In the Hong Kong variety, basically the high level tones is assigned to syllables that bear stress in British English. So in a way, roughly speaking, the H tones is associated with the lexical stress. And M tones is assigned word initially when there's no H tone specified. In other words, M tone is a default tone, it's an unmarked default that will be assigned as long as there's no H tones. And on the right, I'm showing some example words that are analyzed using this tonal system. And another piece of information is that there is some correspondence between the tones in Hong Kong English and the tones in Cantonese. So, for example, the study of Liang 2016 have found that the high level tones in Hong Kong English matches the level of Cantonese high level tone. And then the mid-level tone in Hong Kong English matches the Cantonese tone 3, the mid-level tones for some speakers, whereas the L tone has no matches. So in a way, the tone 1 and tone 3 of Cantonese matches the prosodic tones in the Hong Kong English. These tones satisfy the triggering hypothesis, but they are shared prosodic features between Hong Kong English and Cantonese, so that these tones should have the potential to facilitate code switching between Cantonese and English. And then we found that tone 3 seems to be preferred over tone 1. We suspect it's due to the preference of the step-up pattern. So we observed that they might want the pitch to raise a bit. And then for tone 3, if we assign a tone 3 before the code switch point, then the step-up pattern is more natural compared to a preceding tone 1. So this is our very preliminary phonological explanation, and we are currently working on the further develop these findings, especially to find that to what extent the step-up pattern is prevalent in Cantonese-English code switching, and we are analyzing the audio recordings at the moment. I think the audio recordings will be able to tell us more about the actual prosodic effects, because currently relying on the categorical tone information in transcription, there are a few limitations. For example, in Hong Kong English, in Hong Kong Cantonese, certain tones are reported to undergo merger. So this effect cannot be captured using the text data. And also for the neutral tone category in Singaporean Mandarin, we have no knowledge of how its actual realization is, whether it's because it's quite different from the standard Mandarin. So, but we are not sure whether it's merged with other tonal categories or it's maintained as a separate tonal category. So we hope to be able to further explore on this question. And it's our reference, and thank you all for listening.